Hey guys, so the Gestapo kicked me off campus so that I couldn't finish the talk earlier. So, welcome to my garage instead. Yeah, I know, it looks a lot like a classroom though, but it's got chalkboards, so it's better. So let's see, we needed to finish talking about lines. And we got through most of the stuff I wanted, but I want some examples for you guys. I also want to kind of iterate the difference between what we were thinking before and what we're thinking now. So before, in say algebra 1 or something, we were thinking y was mx plus b, right? We're remembering from the other video that m is the slope and b is the intercept, right? So in this class, what we're going to do is we're going to sort of step our thinking a little bit to the side, and we're going to think about this thing as a function, right? So as a function, what I mean is really, we're going to say, okay, here's a rule. F of x is mx plus b. So for a given value of x, right, f is a function that transforms that into a, well, what we used to think of as a y, what we're now thinking of as an output, right? So, sorry, my phone battery's dying. So what we want to do is we want to think about this and its relationship to this other thing that we think of as a line, right? Which is maybe something like this, right? We think of this guy as a line, and we think of this guy also as a line. So in what way are these the same thing? I'm kind of wondering. I call them both a line, but what do I mean by this? I hope you guys are noticing that this is probably the graph of that rule, right? So here we have a function rule written out, and here we have a graph of a function. So remembering the definition of a graph, these are points. They're points x, comma, f of x pairs, assuming that here we're drawing the graph of the function f. Pretty cool with that? I'm going to assume you are, since you can't talk back. All right. So we need a couple examples. I would offer you the choice normally as to whether you wanted to learn the real world example first or the kind of dumb example. I'm going to give you this sort of real world thing, and then we're going to do a slightly easier thing after that. So the real world thing is this thing called linear regression. And this linear regression is sort of a stats topic. It comes up actually in a lot of places. This is probably the #1 thing that lines get used for in real life. It's also probably the #1 thing that stats gets used for in real life. So this is kind of a big deal. The idea here is actually not super hard. The idea is I have something like some data, which might look like this. So I have some data points, and we should probably give this some meaning. So maybe my most recent example for this was buying a house. So say this way, I've got square footage, which my realtor told me was maybe the most important variable for buying a house. So I have square footage, and then this way, I have sale price. Okay, and here are some homes that sold, right? So each point on this will be something like a square footage. Like say this one's a fairly big house, that one might be 2,500 square feet. And it has a sale price, and the sale price might be, oh, I don't know, $300,000. So 300K here. That comma's confusing, so I'm going to drop it. So we've got one of our points on our graph. This one is 2,500, comma, the sale price, which was $300,000. Okay, and now these are homes that have sold, right? These are data that I've collected. And I may be interested in something like this. My square footage on the house I want to buy is like here. So I'd like to know maybe some kind of a, what should a fair offer look like, right? So the way we do this is we cram it into some kind of fancy formula like Excel. And actually people are really good at this. So I hope that you guys can see that there's kind of an upward trend to this data. So most of you are probably pretty good at noticing that really a line through that would look about like this, right? Maybe we'll make that end a bit longer. So if we want to find out what a fair offer price for this square footage would be, we'd follow this square footage up to our line, and then we'd follow it over to the sale price that corresponds. So this is maybe what our fair offer would be. I haven't put any axes on here, so that's a little bit hard to follow. Another way to look at this would be to say get a formula. So out of Excel, maybe I get a formula. So I get like P, right? Sale price is, and I think the one I got for when I was shopping around here was 145F plus 68,000. Okay, so this is a function, right? P is a rule. It takes something and turns it into something else. It takes square footage, right? Footage over here, P, and then turns it into, well, P of F, right? Really, if I was maybe suppressing my notation a little bit less, I would write this. So it takes a footage and it turns it into a P of F, which is a sale price. Or at least an estimated sale price. Okay, so what does the slope mean here? And what does the intercept mean? These are things we can actually interpret, right? This is my intercept. This is the value of a 0 square foot house. That seems stupid, right? Yeah, kind of stupid. But has a good interpretation. What's buying a 0 square foot house? Well, really, I don't think 0 square foot house. Instead, I think the lot that the house is on, right? That actually makes sense. And it turns out 68,000 is about a reasonable price for a lot. So I think I'm good with that. Now, what's this number? This is the slope, right? Which we think of as a rise over a run, yeah? So what's a run in this case? A run is a one unit increase in the input. That's a square foot. So this 145, that represents $145 per square foot. Does that make sense? I sort of hope it does. Nobody can ask me anything now because of this silly video format, but I hope that follows. Okay, maybe we do another different example. So let's do a kind of a dumber, more mathy example that has less kind of weird variables in it. So the other thing we might want to do with lines is like say put a line through a couple of points. And this will help you do your homework. So let's do that. Let's do, for example, find an equation for a line through, I suppose, instead of between. Through is better language. Through 1, 2, and 3, 5. Okay, so how do I do this? Well, there's sort of two approaches. I'm going to start with the graphical kind of idea because I think that's a bit more intuitive, and I think that's going to be especially useful since you can't kind of ask me questions in this format. So let's try the graphical idea. So here's some axes, right? Put some ticks on the axes maybe. Okay, so let's see. I want to graph the point 1, 2. So how do I do that? I should go over 1 unit, right? And then up 2. So here's the point 1, 2. Okay, now I should graph the point 3, 5. So I go over 3 units, up 5 units. So I get my point 3, 5 here. Now I should be able to draw a line between those. Okay, so I do that. There's a line between those. This is my, I don't know, I haven't named anything yet. Maybe if we call this the x-axis and the y-axis, that'd help. Maybe I'd call this f, right? Okay, what do I know about f? Well, a lot of you probably observed that this line kind of goes up from left to right. That means that there's a positive slope, right? So my slope is positive. Well, I can do a bit better than that, right? Can I calculate this slope? Should be the what over the who? Maybe the rise over the run. So if I draw this little triangle in here, how long is this side? Well, conveniently for my picture, I can just count that off, right? It's 1, 2, 3 units long. How far is my run? Well, my run is 1, 2 units. So what's my positive slope? In fact, it's not just positive, it's 3 halves, right? So I found m, right? M is 3 halves. That's part of the way to finding an equation, right? Now, this other bit's harder, especially using the graphical idea. I would like to eyeball how far up the intercept is, right? So I would maybe guess something like b is approximately a half, but I would like to do a bit better than that, right? So to do a bit better than that, I'll use my information that I found about m and my idea that this ought to be a line. So lines look like y, or f of x maybe, right, is mx plus b. Okay, what do I know about mx plus b? Well, I know I can take the m out, replace it with 3 halves, right? Okay, what do I know about x and f of x? Well, those should be things on a graph, right? So I need to find something on the graph. Oh, very conveniently, I have things on the graph. So you can use either one of these, it doesn't matter which. Let's use this one. So if we plug that in, which one's the x? So I need whatever the x is here, plus b, and whatever the y or f of x is there. So the f of x is the y coordinate, right, the second coordinate, so that goes here. This gets the 1, the first coordinate. So again, I'm using this point. And I'm kind of thinking about this point. I'm thinking, okay, this is the x value, and this is the y, or the f of x value for this one. Okay, see that? Okay, so now how do I solve for b? What should I do? Well, this is 3 halves, right? I want to isolate b, so I should move that to the other side. So I get b is 2 minus 3 halves. And then I think, okay, 2 is 4 halves. Right, that's multiplying top and bottom. Really, this is 2 over 1. I'm multiplying top and bottom by 2, so I'm not changing anything in that. So I know that 2 is 4 halves. Minus 3 halves is 1 half left over. So my line's equation is y, or f of x, equals 3 halves x plus a half. Cool? So we found this. That's our equation. Keep in mind that's an equation. There are going to be a bunch of equations that are going to look pretty similar later when we start doing more of these. But this is an equation. Cool? And we could check our equation by plugging in the other point, right? If we plug in 5, we ask, okay, is 5 equal to 3 halves times 3? Wait, 5, yeah, the y, right, equals maybe 3 halves times 3. Oh, I need to add my half still, right? Okay, so I'm wondering, are these equal? Well, this one is equal to 9 halves plus a half. Okay, that's 10 halves. So are these equal? I think yes, they are. So check. Right? This goes through both points. It goes through 1, 2 because I forced it with this. and it goes through 3.5 because I just checked that. Cool? Alright, this is what I wanted for 8.2, so please get started on the 8.2 homework. Thanks guys. Sorry that class was weird today. Bye.